we have been specifically only doing reactions between aldehydes and ketones in the case of aldol, and then we were doing the same thing in the case of the Claisen reaction where we're doing esters. So the question here is, if I could preform any nucleophile, regardless if it's an ester or nucleophile, I can do that using a strong base. So here I have a ketone, okay, and I'm using a strong base. And now what's interesting is I'm taking this nucleophile, this preformed nucleophile, this ketone, and I'm not reacting it with another ketone. In this case, I'm reacting it with an ester. This could have been an acyl chloride. So the whole idea is, if I could preform any nucleophile, I can introduce whichever electrophile I like. It doesn't necessarily have to be an aldehyde. It doesn't have to be a ketone. For all we care, this could be, and you learned this in the last chapter, this could be an alkyl halide. This could be an epoxide. So again, I don't want you to compartmentalize. You've learned a lot of different electrophiles. Okay, in chapter 22, you were focused specifically on alkyl halides. Okay, in this chapter, we're focused on carbonyls. But, you know, another example could be, and you guys learn how to do this, was what if I gave you a epoxide? Would epoxides open up with this strong nucleophile? And the answer is yes. In fact, I have something in chapter 24 that will look at that to make ring systems. Okay, so again, the whole idea here is we have something called directed reactions, where if I have an enolizable proton, as long as I use a very strong base, I get 100% formation of this preformed nucleophile. I can add any electrophile. So in this case, rather than add a ketone here or an aldehyde here, I'm adding an ester. So notice that the product here is, in the case of an aldol, it was a beta hydroxy aldehyde or ketone. In the case of an ester, it was a beta ketoester. But now that I introduced a ketone to start with this ester, I'm basically forming a 1,3-diketone. So the whole idea, ladies and gentlemen, is that we can make any type of active methylene employing this type of stuff. So imagine if this was a nitro group here. So if this was nitromethane, could I take a strong base and make 100% of the CH2 NO2 minus? Yes. And then what if I introduce some system? Now I would have a nitro group here. Or if I like, what if I had a nitro group here and an ester? So I can almost make this whole family of active methylenes just by employing this type of stuff. Okay, so again, I don't want you to get compartmentalized with the way you're looking at this stuff. This could be a cyano group here. Okay, so if I had a cyano group, can we do nucleophilic addition to it? Yes. Could this be an aldehyde? Yes. Again, any preformed nucleophile can then react with any electrophile. So all I'm showing here is the example of taking a ketone to making a preformed nucleophile and treating it with an ester. Okay? Notice back when I talked about directed aldols today, we specifically made this enolate, and then I treated it with an aldehyde, right, to give me this mixed aldol product. Okay? Today, I'm saying, okay, we could do this, but instead of just limiting ourselves to aldehydes and ketones, I can add this nucleophile to any electrophile. And that last example was an ester, but it could have been anything, any electrophile.